Going on, guys? My name is Amos and I'm really pleased to be here with you guys. So today I want to propose this problem to you. So we want to solve this problem, the integral of 11 minus 3x over divided by x squared plus 2x minus 3 dx. We want to look at a technique known as partial fraction decomposition. That is what we want to do first before we find the integral. Alright, let's get started. Oh, I actually forgot to mention that this is actually the very first video in the series Daily Mathematics. So it's going to be a very fruitful journey and I really hope that you guys stay tuned. Let's first of all look at what we have here. So we have a quadratic equation at the bottom, x squared plus 2x minus 3. So we actually have to find out whether this quadratic expression is factorizable or not. To do that, we have to calculate its discriminant. So if the discriminant is positive, then we will know that this quadratic expression is factorizable. So let's calculate the discriminant. We know that d is equal to b squared minus 4ac. So here a is equal to 1, b is equal to 2, and c is equal to minus 3. So if we substitute here, we'll have 2 squared minus 4 multiplied by a, which is 1, multiplied by c, which is minus 3. Now this is 4 plus 12, which is strictly positive. Therefore, this quadratic expression is factorizable. Now let's express it into its factors. So basically, we'll use the factorization method to factorize this quadratic expression. It's simpler than using the quadratic formula. So what do we have here? So let's find the product, the sum, and the factors. So the numbers that we are looking for are two numbers such that if multiplied, we will get the product a times c. In this case, a times c is minus 3 because 1 times minus 3 is minus 3. The sum here is 2. That is the coefficient of x, which is equal to b. So what two numbers can we multiply to get minus 3 such that if we add them again, we'll get positive 2. It's easier to see that it is 3 and minus 1. You basically look at this number here. Alright. Now this simplifies to x squared minus x plus 3x minus 3. Now this is equal to x minus 1 plus 3x minus 1. This is equal to x plus 3 x minus 1. Alright, this means that the rational fraction 11 minus 3x over x squared plus 2x minus 3 is actually equal to 11 minus 3x over x plus 3x minus 1. Alright, so now you have to think of this rational fraction as the sum of two fractions which we are calling partial fractions. Alright, so if we break this down into two partial fractions, it will be easier to find the integral. That's the reason why we are going through this process. So this is actually equal to some constant a over the first factor, which is x plus 3 plus b over the second factor, which is x minus 1. Alright, so now I'll rub out this part. Alright, it's not important. It was just to show you what is happening. Alright, so let's now focus on this problem. So we'll now find the value of a and the value of b. So to find the value of a, we multiply the denominator x plus 3 throughout. So I'll put everything in square brackets and I'll multiply x plus 3, this factor, throughout. So this will leave me with 11 minus 3x over x minus 1. Alright, and we'll basically have to choose a certain value of x that will simplify our calculation. We'll see what value of x is. You can actually pick any value of x, but we want to pick the simplest one, the one that is going to help us get to the value of a quicker. So now here we'll have a, here we'll have b, x plus 3 over x minus 1. So the value of x that we are going to choose is going to be minus 3. Why? It's because if you substitute minus 3 into this equation, this part here goes to 0 because the numerator is going to be 0. All right, and 0 over a number that is not 0 is 0. All right, so this is supposed to give us a. So a is equal to 11 minus 3 minus 3. This part goes to 0, remember, and this is minus 3 minus 1. So minus 3 minus 3 multiplied is positive 9. Positive 9 plus 11, that is positive 20 over minus 4. So a is equal to minus 5. So we'll do the same for b, but we'll now multiply by the denominator x minus 1 throughout. All right, so we'll have x minus 1 multiplied by 11 minus 3x over x plus 3, x minus 1, a over x plus 3 plus b over x minus 1. All right, so what is this going to give us? Oh, it's simple. So let me just rub out the second part so that we give ourselves enough room. So this will be 11 minus 3x over, now this will be x plus 3, and now notice that here we'll have a and x minus 1 over x plus 3 plus b. So what value of x are we going to choose this time? So notice that we have to choose positive 1 because this thing is going to go to 0 because this numerator is going to be 0 if we substitute 1 here. So we'll have 11 minus 3, 1 over 1 plus 3. Now this is equal to b. This part goes to 0. So basically we shall have so this is 11 minus 3, which is equal to 11 minus 3, which is 8. Now 1 plus 3, which is 4. 4 into 8. 4 into 8 is 2. So we have that a is equal to minus 5 and b is equal to 2. All right. So we can then write our rational fraction from before, from at the top there. We can write it as, so we have 11 minus 3x over x squared plus 2x minus 3 is equal to, oh, what did we have for a? For a we had 2 over x plus 3. And what did we have for, no, a was minus 5. A was a minus 5. Let me just grab this. A was a minus 5. So we had minus 5 over x plus 3. And we had that b was 2 over x minus 1. All right. So if I actually take the integral of the first rational fraction, now this has to be equal to the integral of this d dx. Now, if you have two things that are expressed as a sum, and we want to find the integral of their sum, so it's actually taking the integral of the individual parts making up the sum. So this is actually equal to the integral of minus 5 over x plus 3 dx plus the integral of 2 over x minus 1 dx. Now this is equal to, now 5 is a constant, so we can take it out of the integral. So this is going to be minus 5, the integral of 1 over x plus 3 dx. Same for 2. 2 is a constant. We can take it out of the integral. So that is x minus 1 dx. Let me just wrap the top part to give us enough room. Okay, so what do we have now? So what is the integral of this? Now, this is something that you already know. This is minus 5. At least I'll make that assumption. So this is minus 5 natural log of, now we have to put x plus 3 in absolute values because we don't know whether this evaluates to something that is positive or something that is negative. All right, if it evaluates to something that is negative, we know that natural log of something that is negative is, we can't find that value. All right, so that's why we put it in absolute values. So here we shall have 2 natural log of, again, x minus 1. All right, now plus a constant c. So now this is a value of your integral. Thank you very much for watching, and I'll see you guys next time.